So, in last class we have demonstrated the measurement of surface tension of a liquid by capillary rise method in our laboratory. So, now let us analyze the data and find out the surface tension of water. So, we used water as a liquid during our measurement and we will calculate the error on the measurement. So, the working formula was surface tension gamma equal to rho g r h plus r by 3 divided by 2. So, rho is the density of water, g is the gravitational acceleration, r is the radius of the capillary tube and h is the height of the water column from the surface of the water of the container. So, in this experiment we have seen that measure ends, what are the parameters we have to measure. So, that is just simply height h and radius r, height h and radius r. Okay. So, radius of the capillary tube and height of the water column from the surface water surface of the container. Okay. So, these capillary tubes are inserted into the water taken in a beaker, okay, its container, and then this water will rise in the capillary tube. So, from the surface of the container water, what is the height of the water column in the capillary tube. So, that is the basically h. So, in laboratory you have seen that we have used travelling microscope for measuring h and r. So, least count of the, it has two scale, vertical scale and horizontal scale. So, during the measurement of height we have used the vertical scale and during the measurement of r we have used the horizontal scale of the microscope. So, but for both scale the vernier constant is a minimum smallest division in main scale, that is 0.5 millimeter, means 0.05 centimeter, and it have vernier scale have total 50 divisions. So, it is basically vernier constant 0.001 centimeter. So, then we have seen in laboratory the setup and how we are taking the reading in the laboratory that we have seen. So, in this experiment the value of surface tension is very sensitive to the temperature of water. Okay. So, that is why it is very important to note down the temperature of the water or temperature of the laboratory. Basically, the water temperature will be same as the temperature of the laboratory. Generally, in general, if you do not cool or heat, so it will take the in equilibrium, thermal equilibrium, it will take the same temperature as the temperature of the room. So, temperature of the laboratory was 28 degree centigrade. So, that we should note down. Now, table 1 here, this measurement of height of liquid column, okay, as I told that h we have to measure. So, we will use vertical scale of the microscope, that we have seen that we have used the vertical scale of the microscope, and Vernier constant here you should note down. So, in during experiment we have seen that we took uh, three tubes of different radius, tube 1, tube 2, tube 3, and so reading we have to take basically microscope reading for the position of lower meniscus of liquid, that is H, say H, and lower tip of the needle. Okay. So, this needle tip is basically just touching the surface of the water of the beaker, where we have we inserted the this capillary tubes. Okay. And this so, if this is H 0, so your height of the liquid column or water column, it will be height of the liquid column, it will be basically H equal to difference between H and H 0. Okay. So, here you note, you see that we have I have written this unit, it is very essential and very important. So, all the time you should mention the unit, in which unit you are basically noting down the reading. So, yeah, so I was doing, so there is a shortage of space. So, just I have so extended this row. So, but it is not yeah. So, I think one should do more carefully this table, so that this type of things it's not good to happen. So, basically microscope we focused at the bottom of the meniscus, that is we are telling lower meniscus, okay, and then take reading, main scale reading in centimeter, then vernier scale reading, then total reading, okay. And here basically one should take for each observation for each tube. So, here basically you should take reading 3 times, okay, and then take average of it, Similarly, this for lower tip of the needle, basically this top surface of the container. So, there now you focused this microscope at this lower tip of the needles, and then take reading, main scale reading, vernier scale reading, total. Again you should take 3 readings for it, and then take average of it. So, this is the average of it. So, difference of these two is the height of the water H. So, it is a 1.401. Okay. So, so here you just keep, you see here after decimal this two digits, okay, and here after decimal 3 digit, okay, because here main scale reading. So, here accuracy is 0.05, right, main scale reading accuracy 0.05 and up to second decimal, okay. But this, since it is the 3 after decimal, these 3 digits are there. So, ultimately accuracy we can get using the vernier scale, accuracy we can get up to 3 digit after decimal, okay. So, here and here, so this is the difference. So, that way you should not put, say here 0, then here 10.30. So, one can write 10.3, and most of the time we write, but it is not the correct way to write. So, here if you have to write, you have to maintain up to 2 digit, you know. So, this is the important, here up to 3 digit you should maintain, okay. and result is of course up to 2 digit 3 digit you can you have to maintain. Okay. So, this is for tube 2, tube 3 same way one should take data, we took data, but here I have not noted down. So, it is H for this tube 1 this, for tube 2 this average height and this for 3 tube 3 this the height of a liquid column. So, this is the basically height measurement of liquid column. Then second table 2, table 2 is basically next measurement of next parameter, measurement of radius of the capillary tube, right. So, Vernier constant of horizontal scale, it is 0.001 centimeter, horizontal scale of microscope that I have shown you in laboratory. Okay. So, now we are measuring the radius of the capillary tube. So, there are 3 tubes. So, let us focus tube 1, okay. Tube 1 this whole of the tube 1, okay, inner whole of the tube 1. So, now that cursor you set at the inner left wall of the tube, that is R 1, and take reading, main scale reading, Vernier scale reading, total reading and average, as same way for height we have taken reading. Similarly, inner then you focus, just shift, it is already focused. So, now just shift this cursor to the inner right wall of the tube that I showed you in during the measurement in laboratory, but the process I told you, but I think when you are taking video we could not show this exactly the focused this focused capillary holes, but I just mentioned and told you the procedure. So, this is the inner cursor, you set, just shift it to the inner right wall of the tube. So, that reading say R 2. So, for tube 1 again you take 3 reading and from there you take average. Okay. So, that is the reading R 1. Similarly, this is the reading R 2. Now, radius is basically this, that R 1 minus R 2 or R 2 minus R 1, that is the basically diameter, divide by 2, that is the radius R. Okay. So, we found the radius R is this 0.111. Similarly, for tube 2 0.0 I think 0.086, for tube 4 tube 3. So, this is 0.086. Now, these two radius are more or less very close. So, either I do not know, we should not take this very close, these two radius, either some error in measurement of one of them, or we should take radius, we should take capillary tube having quite different. Here difference is 0.3, 0.03. So, here also similarly it could be 0.05 also or 0.06 range. So, let us see. So, now we have measured we have data for radius R and we have data for radius for water height, liquid column water column height, that H. Okay. So, now we will be able to calculate the surface tension. So, let us make table 3. So, calculation of surface tension, here important is at which temperature. Okay. So, that we should mention, because as I mentioned the surface tension is very sensitive to the temperature. it varies. So, we should tell that this we are measuring surface tension, whatever value we will get, that is at temperature 28 degree centigrade. So, again for tube 1, 2, 3, then height of water column, this for tube 1 is this, tube 2 is this, tube 3 is 1.438, okay, and corresponding radius of the capillary tube is this, this and this. Here I can see this is the smallest radius. So, if smallest radius water column, this height will be higher. So, it is the highest, that is fine, and this is the highest radius. So, liquid column should be lowest one, and that is what it is 1.401, and this the you see now this. So, this is in between, this is in between, radius is, although it is close to it, but so although it is close to it. So, water liquid height, it is it's supposed to be close to this value, you know, it is close to this value, but it is supposed to be close to these values. Okay. But it seems it is looks to us that it is close to this value. Okay. So, something wrong in the measurement. From here I can tell you, because I have, so my student has taken, my TA has taken this data and calculated. So, so from analyzing this, seeing this data, I can tell you there is a something wrong in the measurement, either in height measurement or in column measurement. So, so this is close to this one. So, this reading, it should be close to this one, but it is not the case, it is becoming close to this. So, there is a some. So, this is the way anyway, but there may be mistake, that is why we are taking for 3, that is why we are taking for 3 R, okay, so that we can average out, okay. So, that is the reason, because there may be some mistake. If you just measure 1, if it is mistake here, so you cannot find out. So, if you measure this for 3 radius and seeing this one, I can tell, I can see that something, somewhere something wrong, but it may happen, and rarely it happens. Okay. So, that is why we take more sets of data and we take average, so that we can minimize this error. Okay. So, this average of this the surface tension, basically it's a say 74 dyne per centimeter square. Okay. So, after calculation we got this one. So, but if we see the table supplied, I think this from data sheet, if you see there is a true value of this surface tension for water at 25 degree centigrade, it is 72 dyne per centimeter. Okay. So, in our case it is 74, is very, it is close to this true value. So, I think this measurement is quite okay. And another difference, it is at 25 degree centigrade, and in our case here we have measured at 28 degree centigrade. Okay. So, generally, why it is higher value, whether I should justify in terms of temperature? No, I cannot justify, because when with temperature increment, if temperature increases, this surface tension decreases. Okay. In case of water, surface tension decreases. So, it so at 28 degree centigrade, the true value 28 degree centigrade true value, it will not be 72, it will be less than 72. So, but it's I think it's between 72 to 71. So, this at 28 degree centigrade. So, it will be slightly lower than 72. Okay. So, I cannot tell why it is higher. So, that is because this temperature are different, that I cannot say. Okay. Because it should be at higher temperature, it should be lower value. So, this way we can compare with the standard value, true value. Okay. We should compare. So, that is what we have done. Now, we will do this error calculation for this measurement. This gamma equal to, this is the working formula. So, rho g to this part is constant. So, I have written k. So, k r h plus r by 3. Okay. So, gamma equal to this. So, this is the multiplication of 3 1 2 and this term. Okay. So, multiplication division rule tells the relative errors of each parameter will be added. Okay. Each term will be added. So, del gamma by gamma equal to del r by, because this is the constant, it del k is 0. So, r del r by r plus del h plus r by 3 by h plus r by 3. So, this we are taking as a whole one term, one parameter. So, relative errors of each term are added. So, that is what we have done. Now, this part is basically from that rule, the summation and subtraction rule. What is that? So, if for summation or subtraction, this absolute error of each parameters will be added. Okay. So, that means this will be equal to del h plus del r by 3 is there, it is constant. So, it will be there. So, you put it back here. So, you get this one, then you put this value del r and del h, you know this 0.001. So, just calculate it, it will come around not exactly 0.01, but I think it is 0.098 something. So, I have put this too. Okay. So, this error, so then this delta gamma by gamma is this. So, delta gamma equal to this into 74. So, the 0.74. Okay. So, this for tube 1, similarly you can calculate for tube 2 and tube 3 and then take average. Okay. So, I have to, okay, just more or less, okay, if this is the average value. So, then I have to write result. So, this gamma at 28 degree centigrade equal to 70. If this is the error, then you should write 74.00 plus minus 0.74, or you can write 74.0, then plus minus you have to write 0.7, or you can write 74 plus minus 1. Okay. So, if it is 1 decimal point, so here also it should be 1 decimal point, 2 decimal point, so it should be same, and no decimal point, it should be this one. So, I would prefer to write this one, because this with temperature, this variation is for I think for 5 to 10 degree centigrade, it varies, it's decreased by 1. So, if it is at 25 degree centigrade, if it is 72, it is at 35 degree centigrade, it will be 71, 45 it will be around say. So, so this variation itself with temperature, so it is not in decimal point, it is just in last significant number, change in last significant digit. Okay. So, that is why I would prefer to write 74 plus minus 1, the result should be this. So, this is the analysis of data and error calculation and the result of surface tension of liquid we have measured by capillary rising method. So, yeah, I think I will stop here. Thank you for your kind attention.